How's it going, guys? This is Joshua from Motiva Online Instructors. Today we're going to be talking about the 1998 Harvard MIT Math Tournament for our last question of the calculus part. It states, let S be the locus of all points x, y in the first quadrant such that x over t plus y over 1 minus t equals to 1 for some t between 0 and 1 open. The question is, find the area of S. To be able to do this, we need to isolate t from the equation. So if we multiply by both sides by t, this t cancels, and we have x plus t over 1 minus t, y equals to t, and then multiplying by 1 minus t in both sides, we have 1 minus t, x plus ty equals t times 1 minus t. Now let's distribute x times 1 minus xt plus yt equals t minus t squared. Now we isolate for 0, and we have t squared minus t minus xt plus yt plus x equal 0. Now the point of this is that you notice that if we have t as a variable, we can use the quadratic equation. 1 minus x plus y plus x equals 0. And the quadratic equation states that it's going to be b, which is this term, minus b, plus or minus the square root of b again, 1 minus x plus y, squared, minus 4ac, which is x. Everything divided by 2. Now notice that for this radical to make sense, the discriminant of the quadratic equation has to be greater or equal than 0. So let's do that. The discriminant here is 1 minus x plus y squared minus 4x has to be greater or equal than 0. Now if we expand this squared, we get the discriminant is going to be equal to y squared minus 2x plus 2 y plus x minus 1 squared greater than or equal than 0. Now again, notice that in this case, y is going to be the variable and x is, and the other terms are going to be the constant. So let's use again the quadratic equation. So y is going to be, y1 and 2 is going to be minus b, which is 2x plus 2, plus or minus the square root of 2x plus 2 squared minus 4x minus 1 squared, and everything divided by 2. Now notice that this term squared minus this term squared, we can factor it into what? Well, by pre-calculus, we know this general rule of a squared minus b squared is a minus b times a plus b. So 2x plus 2 plus 2, right, x minus 1 times 2x plus 2 minus 2x minus 1. And everything again over 2. Now this becomes 2x plus 2 plus or minus the square root. Well, 2x plus 2x is 4x. And 2 minus 2 is 0. Now 2x minus 2x is 0 and 2 plus 2 is 4. Now 4 times 4 is 16. The square root of 16 is 4. So we can plug out that 4. We just get x over 2. Now we can factor 2 in all the terms. to cancel with this 2, and this becomes now x plus 1 plus or minus 2 square root of x. Now, the question is, what y's, right, because this is y1 and 2, should we choose? Because we have y1 being x plus 1 plus 2 square root of x, or y2 being x plus 1 minus 2 square root of x. Well, to be able to choose here, I need to show a proposition first. So let's prove a proposition is given 0 over greater than t greater than 0 and less than 1, I'm going to prove that x and y are less than 1. Okay, proof. As case 1. Assume the contrary. So we're going to prove by contradiction. And that means that x, y is greater than or equal than 1. Case 1 is that x and y are equal to 1. If this is true, then by the equation we have 1 over t plus 1 over 1 minus t equal to 1. But t being trapped between 0 and 1, this means what? That t is greater than 1, and let's do a little calculation here. 0 greater than minus t, greater than minus 1, 1 greater than 1 minus t, greater than 0. This implies that 1 over 1 minus t is greater than 1. Now, if we add these two together, this term and this term, then we have 1 over t plus 1 over 1 minus t, both greater than 2 plus 1 plus 1, which is 2. But this contradicts the fact that this is equal to 1, right? 1 greater than 2. It's a contradiction here. Now, case 2 will be what? That x and y are greater than 1. By the same reasoning, we have that if we multiply x and y greater than 1 to t and 1 over t and 1 over 1 minus t greater than 1, this implies that x over t is greater than 1 and x over 1 minus t is greater than 1, right? Because it's 1 times 1, 1 times 1. Sorry about that. It's y 1 minus t greater than 1. So again, we have that x over t plus y over 1 minus t is going to be greater than 2, but this is 1 greater than 2, which is a contradiction. So we have proof that in fact, if t is between 0 and 1, then x and y are less than 1, strictly less than 1. So again, which one to choose? Well, to make this less than 1, we have this 2 value here, and clearly if we add 2 to this equation, then this is going to be greater than 1 automatically, just because we're adding all positive numbers. Now for this case, we subtract 2, so this one is going to be the one that we're going to choose, because this one is going to be less than 1. Okay, so this means that we just found the y that satisfy all the conditions. Now, the question was find the area of S. Well, S is all the x and y components that satisfy the condition. So being y equal to x plus 1 minus 2 square root of x, And being this y between 0 and 1, then we just find the integral of this function from 0 to 1 to find the area. So the area of S is going to be the integral from 0 to 1 of the y that we just found, which is x plus 1 minus 2 square root of x dx. Now this integral is x squared over 2 plus x minus 4/3 x to the 3/2 evaluated from 0 to 1. Now in 0 it's 0, and in 1 is 1/2 plus 1 minus 4/3, which is 3/2 minus 4/3, which is 1/6. And this is our answer, guys. Thanks again for watching. Please subscribe to Multival Instructors, or go to our website or our Facebook, or tweet us at Multival LLC. Thanks again. Thank you.